Welcome to the first video in my Python two-dimensional battle simulator series where we're going to be making a project like this. There's going to be a large map of Europe and we're going to see players of different teams converge into groups and attack each other. These are all just soldiers. They're represented by little boxes. And right now I haven't coded the portion where they start killing each other, but this is essentially how the simulator is going to work. We're going to have large groups of enemies on the map. They're all going to go near each other and attack. And I thought this would be a really fun project to do. This is going to be a lot like my Slither.io series that I also have, but I frankly recommend you watch that first because this series I'm going to be moving faster. The explanations are not going to be as in depth. I'm going to assume you already have used Pygame and you already know how to code in Python. So if you are lacking in one of those areas, I'd recommend you would go to Slither.io first before you would watch this one. So what I'm going to do, I'm using the PyCharm editor. I'm using PyCharm. I'm going to create a new project for our battle simulator. And I'm going to call this 2D Battle Simulator. And I'm going to create, and I'm going to do it in a new window. And what we need first is to take a lot of those items that you saw a second ago. We had a picture of Europe, a bunch of boxes. All of those are textures that I will be providing in a link in the description, but they are all here on my desktop. So once you download them, all you need to do is click and drag them over the name of your project and click refactor, and that will add all of those to your project here. So we now have the map of Europe in our project, the yellow soldier, red soldier, green soldier, very simple textures. And one more thing before we start the coding, we need to make sure that Pygame is installed. So I'm going to go to File, because Pygame is a library we're going to be using, Settings, and then Project, and then Python interpreter. I'm going to click on that. I do not have a Python interpreter selected. I'm going to click one. I'm just Python 3.9 is what pulls up. That's not really my big concern. What I'm concerned about is that whether or not Pygame is installed. So once you select an interpreter, what you do is you click on this plus sign and you type in Pygame. And once you see it, you can click install package and it's going to take a second and then install the package. And it says here that the package installed successfully. So I'm going to click apply and OK. So now we've done all the setup for this project. We have all our textures and we have Pygame installed on PyCharm. So again, I'm going to move a little bit quickly through this video. All we're going to do is set up the main components of the game, getting the main game going and getting the soldiers to draw on the screen. So in the main.py file, I'm not actually going to code much from here at all. I like to use classes. So I'm going to right click on the name of the project, click new Python file, and I'm going to type main game.py. I am going to be using a main game class, which will handle the game, its rendering, its drawing, and all its entities. So I'm going to first import Pygame, since we're obviously going to need that. And then I'm going to create the class main game, like that. And I'm going to create the constructor for the main game class. And again, if constructor is not really a familiar term, then maybe you should start out with a different series. As rude as that sounds. I don't want that to sound rude. Oops. So I have the constructor here, which I accidentally just deleted. And we need several things for our game. First, we need a window. So I'm going to create the window. Self.window is equal to pygame.display.setMode. But in order for me to actually create a window, I need window dimensions. So I'm just going to create a constant up here, windims, short for window dimensions. And this is going to be a tuple. And I want my window to just be 500 by 500 pixels. So now that we have window dimensions, I'm going to use that to create the window variable here, pygame.display.setMode with our window dimensions. Next thing we're going to need is a background color, self.bg color, and this is also going to be a tuple. I want a background color of just black, so I'm just going to put 0 for red, 0 for green, and 0 for blue. All black. That's our background color. But of course, as you saw in the example earlier, we're not actually drawing a solid black background. There's a whole map of Europe in the background. So we need to load that image. The image is right here in our project directory, but we need to load it in the code. So to do that, we're going to load it like this, self.image, or I'll just call it background image equals, and to load an image, you type pygame.display. Whoa, I got distracted from this. It's actually pygame.image.load, and we're going to need to type in the file path. So for the file path on my computer is Europe map.png, and that's because the picture is in the exact same directory as my main game.py file here. If this was in some kind of textures folder, I would have to type textures / something like that. So make sure your directory is the same. But for me, it's just Europe map.png. The next thing I'm going to do is, let's see, I have the window, the background color, the background image. The last thing I want is I need to create a variable that keeps track of when this game is over. So self.quitGame, this is just going to be a Boolean variable, and I'm going to set it to false to start with. The game is going to keep running as long as this is false. So now let's create the game loop. So I'm going to create a play function, and all this play function is going to do is contain the game loop. What I mean by game loop is this. All video games have just two main components, the game update and the game render. So updating is just all the characters in the game updating their positions, their attacks, their healths. If my character is running, his position is updating. So updates have everything to do with change in your game. Change the health, money, your attack, health, whatever. Change, that is update. But rendering is where you draw all those changes to the screen. And a game loop consists of both of those. So I'm going to create that loop. While self.quitGame is false, we're going to continually update the game and render the game. So first, let me just create those functions before I continue. Define update, and I'm just going to put pass for now, which essentially says you're not ready to finish the function. You'll skip it for now. Define render, and then pass here as well. But these two we're going to draw, or we're going to run continually. So the play function is going to continually run update, self.update, and render, self.render. So this right here is our game loop, and this is where the entire game is going to be run from this function in our main game class. So now let's go ahead and add the update and the render. The update's going to be really easy. All we're going to do is just, since we don't have a character, so we don't need to check for keyboard input, and we really don't have any other user input at this time, so all we're going to do is check and make sure that the user is not clicking the X. So let me go back to the other coded example I made. The only update we're going to do is check when the user clicks this X on the window, and once he does, the game should quit, just like it does there. So we're going to check for that quit. We're going to get all the events for event in pygame.event.get. So this is just a list of all events that happened in the game that have to do with the window. So like, or any keyboard stuff. So if the player presses a button, that's an event in this list. If they drag the window, that's an event. If they click the X button, that's an event. So we're going to use a for loop to process all the events that we just got here from pygame event.get. And now once we have the event, we're going to check if the event.type is pygame.quit. This means the user clicked that X. We are specifically looking for the event that takes place when the user clicks the X. So when that happens, we just need to set quit game to true. Quit game is equal to true. And that's the only thing we're going to be checking for in update. Nothing else is happening in update right now. Render, we're going to do that. That's going to be pretty simple at this time as well. Very first thing we need to do is fill the whole screen with our background color. This essentially erases everything that happened previously. And I'm going to show you what happens when you don't do that in a second. So I'm going to type self.window.fill. So what do we want to fill our window with? The background color here. Self.background color, like that. And then let me just pause here and show you what happens when you don't do that. So this code's going to look slightly different. This is also looking ahead. I'm going to take out that window.fill command and watch what happens as the soldiers move. When they move, all their positions are smearing. So as they move, like take a look at this one here by my mouse. As they move, they are smearing across the screen because those were their previous positions. We're not erasing what happened before, which is why you get that smearing. And you don't want the smearing in your game. So we fill the screen with our background color. The next thing we need to do is we need to draw our background image. And for that, you use the Windows Blit command. Self.window.blit. What are we, I don't want to say blitting, what are we actually drawing on the screen? The image, self.background image. And we need to specify as well in a tuple where we're drawing it. And I'm just going to put the position 0, 0, like that. And lastly, we need to update Pygame and let them know that this frame is complete. Pygame.display.update. And that will update. I really have, to this day, this one is far more confusing to me, but we're essentially updating Pygame here. And that is it. Of course, if we actually run this, nothing's going to happen because we never created a main game object. So I'm going to go to main game, and I'm going to delete all this code here. And all I'm going to do is import the main game class. So from main game, that's the name of the file, import main game, the name of the class, which just happened to be the same for me. Game is equal to main game. So we just created a main game object. And now I'm going to type game.play, which is going to run that whole that whole game loop there. And if I didn't make a mistake along the way, what should happen here is we get the background image. Very good. So now we have our window. When I click the X, the game exits, which means that the updating is working. Now you'll notice something kind of weird here. We only see Iceland here on the picture. Why is that? Because the Europe map is this whole thing. Well, the problem is that if you take a look here in the corner, the dimensions of the Europe map in pixels are 1,914 pixels by 2,048 pixels. But the size of our window is 500 by 500. So we have two options. Either make this bigger to match the size of the image, or shrink down the image to match the size of the window. And the second is a much better option, just because windows are going to be different sizes on different people's computers. So we need to resize this image that we loaded so that it's not just Iceland. So I'm going to resize the image by saying that the background image is going to be equal to pygame.transform.scale. And then we need the first argument is what you're scaling. So we are rescaling the background image. And what new dimensions? Well, we want the background image to match the size of the window. So we're going to put windims, window dimensions there. And that's going to fix that problem because when I run it, now we get the entire map here. And by the way, 500 by 500 is probably small for a window, but we can change that in the future. So now, that's a good portion of the video here. We have the window, we have the basic structure, the skeleton of our game, this main game class, which is going to handle the game loop, the updating and rendering, and we got our background image to the screen. The next thing we need to do is then create the soldiers that are going to appear on the screen. So I'm going to right-click on the battle simulator and add a new Python file, soldier.py. And what I'm going to do here is import Pygame, since we're also going to need it here, and create the soldier class. Class soldier. And inside of the constructor for this soldier, we're going to need a lot of things for the soldier. We need well, let me just put them here in the parameters. We need an X position for the soldier, a Y position, a width, a height, and a file path. Why file path? Because we have a red soldier, a green soldier, and a yellow soldier here. And I need to know which file we're going to load for this soldier, which will depend on what he looks like. So we're going to need all these as parameters, and we're using them all as parameters because otherwise, if I hard-coded the soldier, let me show you what that would look like. First, we're going to create the soldier's hitbox. Self.hitbox is equal to pygame.rect. That's just a pygame rectangle object. It simply has an X, a Y, a width, and a height. That's all a pygame rect is. And the pygame rect object has some built-in collision detection, which is important because we need to know when two soldiers are making contact so that we can start simulating a fight between them. So the hitbox is going to be equal to pygame.rect, and we need an X, Y, width, and height. So I said I was going to show you what the hard coding would look like. I could put 0 for the X, 0 for the Y, and just say that the soldier is going to be 10 pixels wide, 10 pixels tall. But of course, if I hard-coded these numbers in, the soldiers would all be at that same position, and we don't want that. So that's why I'm using parameters here. We're going to let the parameters decide where the soldier is going to be. So we're going to create a rectangle object, but it's going to use the parameters X, Y, width, and height. So the hitbox was the first thing. The second thing is we need to load in that file path. The file path is either going to be greensoldier.png, redsoldier.png, or yellowsoldier.png, just like how we loaded the file here. We're just going to use a variable for this file path instead. So let's create the texture for the soldier. The texture is going to be pygame.image.load file path. And then we're going to have to do the same thing where we need to make sure that the size of the image is the exact same size as the hitbox, because otherwise we're going to get that weird thing where the image is a different size and the collision will be wrong. So what we're going to do is we're going to resize the texture to match the size of the hitbox. So I'm going to say self.texture is going to be equal to pygame.transform.scale. And we are resizing the soldier's texture, so I'm going to type self.texture. And what is the new size? The new size is going to be self.hitbox.width, self.hitbox.height, like that. That is going to resize the texture of the soldier to whatever the hitbox is there. So that's good for the soldier's constructor, and I'm going to go ahead and create two more things for the soldier. Even though the main game has an update function and a render function, every character in the game should also have its own update and render function. Because what the main game's update function is going to do is force everyone else to call their update functions. And that's going to look different. For a soldier, that's going to be moving towards the nearest soldier. For our camera, it's going to be staying in place. Actually, I think, let's see. I don't think we're going to do much with the camera in this game. I think the camera's largely going to stay still. Maybe we'll have controls to move the camera. But essentially, we do want a separate update function for the soldier as well, for each individual soldier. So I'm going to create an update function here. And for now, we're just going to pass. This is going to do absolutely nothing. Our soldiers are not going to move yet. That's going to be for the next video. And we need a render function. And so here what we're going to do is we're going to draw the soldier the same way we drew the background image. But in order to draw the background image, self.window.blit, we needed a window. And the window is here in main game. So what we'll do is we'll just add that window as a parameter. Window, like that. And we're going to say window.blit. We are drawing the soldier's texture. And where are we drawing it? We're drawing it. And I need to put these parentheses so that Python knows this is a tuple. We're drawing it at the hitbox X position, and the hitbox Y position. So that's all. The soldier render function is going to be really simple. It's just window.blit, self.texture, where the hitbox.x, the hitbox.y. And we could have done this in the main game here, but it's better to have this taken care of in the soldier itself. And that's it for the soldier class. Now let's actually create some soldiers in our game. And I'm going to do this in the main game constructor. And let's start with some constants. Red soldiers is equal to 10, so we're going to have 10 red soldiers. Yellow soldiers, also 10. We'll just keep it all even, and there will be 10 green soldiers here. So what I'm going to do is I'm going to use a for loop, and I'm going to create 30 new soldier objects inside this soldiers list. Self.soldiers equals, and then blank. I have this empty list of soldiers that we're about to populate. We're about to create some soldiers. So let's start with the red soldiers. For I in range, red soldiers. And I'm going to, well, first we need to create a random X position and a random Y position, because in order to create a soldier, we have all these parameters here, X, Y, width, height, file path. And really, width and height are not going to be random. The soldiers are all going to be the same size. File path is going to be either red, yellow, or green. But X and Y need to be anywhere on the screen, anywhere on the Europe map. And if you recall, the Europe map in our game is just 500 by 500 pixels. So let's start with a random X position for a soldier. The random X position for the soldier we're currently going to make is just going to be, and I'll need to import the random library, import random, so we can make random numbers. So we want a random X position from, let me type random.randint. We want 0 to 500, because that will be any X of 0 is here, X of 500 is here. So we want the soldier to be anywhere in this range, not past, not before, because that would be outside of our screen. And now, let's create the random Y position. And it's going to be the exact same thing, random.randint. We want a random Y from 0 to 500, because that's also on the screen. A Y of 0 is here, top left corner, and a Y of 500 is down here. So by specifying our size to be between 0 and 500 for X and Y, we're guaranteed to get this soldier on the screen. But of course, we shouldn't hard code 500. We have this windims variable, so let's use it. So let's change this to windims 0, the first one, windims 1. So 0 to the width of the screen, 0 to the height of the screen. And now we're ready to create the soldier. New soldier is equal to soldier. We need a random X, a random Y. The width is going to be, let's just create a constant for the soldier size. Soldier size is equal to 10. Maybe a little bigger. Let's make them 20. So the width of the soldier is going to be soldier size. The height is also going to be soldier size. These will be squares. The file path, well, we're making the red soldiers right now, so I'm going to type red soldier.png. And remember, all of these that I'm putting inside of the soldier constructor correspond to these parameters. X, Y are first, so our random X, our random Y. Then the width and height are next, soldier size, soldier size. Finally, the file path of the soldier, which is going to be the red soldiers here. But of course, this new soldier does not mean anything until we add him to this list of soldiers. Otherwise, it's just going to be deleted. So let's add it. Self.soldiers.append new soldier, like that. And now the soldier, which we just now created using these random position variables, is now a part of our soldiers list. And before I move on, we would get an error if we don't remember to import the soldier class. So from soldier, import soldier, like that. So now what I'm going to do is I'm going to cheat a little bit. I'm going to use copy and paste and create 2 more for loops. Only these will be for the green soldiers and the yellow soldiers. But the logic is the exact same. I just need to change the file path and the number of times we're running this for loop. So finally, just going to change this one to yellow soldiers and change the file path to yellow soldier.png. And so we are almost done with this video here. We've created all the soldiers using these 3 for loops, which generate random positions for the soldiers and put those positions, save them in the hitbox here. But of course, we wouldn't be able to see these soldiers because we need to draw the soldiers and update them. And we don't really need to update them since they don't do anything yet, but we'll go ahead and add the logic for now. So in the main game update, we're going to call each individual soldier's update function. For soldier in soldier. So I'm just going to use this for loop to go through each soldier in the list, and this should be self.soldiers. My bad. So in our soldiers list, we're going to take each individual soldier in it, and we're going to say soldier.update. That's the whole point of the main game's update function. The main game update calls the update for everything else. And that's just a nice organizing trick. That's why we have the main game. And now let's do the same for the render. The main game's render function is going to call everybody else's render function. So we're going to do almost the exact same for loop. For soldier in our list of soldiers, self.soldiers, we're going to call the soldier render function. But this one's a little bit different because remember, in order to render, we need the window variable as a parameter, so we need to give it the window variable, which, scrolling up, as you recall, was the first one we made, self.window. So let me pass in the window variable, self.window, like that. And so now we are updating the soldiers here, and we are rendering the soldiers here. As a quick note, make sure that this is in between the filling of make sure this is in between drawing the background image and updating Pygame. And now let's see if I made any mistakes along the way. It looks like I did somewhere, I misspelled soldier here. So, and that's one bad thing about copy and paste. If you make a mistake, you copied that mistake. I just misspelled soldier here. Let me rerun it. And now, there we go. We have soldiers spread across this map of Europe. Let's make the map a little bit bigger. I'm going to change from 500 to maybe 700 like that. So we got a little bit bigger of a map, and the soldiers, still same amount of soldiers. We have a bunch of red guys here, the yellow boxes, green boxes, they're all spread around. And of course, every single time I run this, they get different positions because we are randomizing their spawn locations. And that's it for this video. We have done the basics for the 2D battle simulator. In the next video, we're going to actually get these soldiers to move towards each other so that we can begin fighting. And then the last part is going to be actually calculating the fight and how it works. Thank you for watching.